video on systems of linear inequalities. By the end of this video, you should be able to graph two linear inequalities on the same coordinate plane. You should be able to shade the linear inequality appropriately to indicate the solution area, and you should be able to determine the solution area for a system of linear inequalities. So let's take a look. What is a system of linear inequalities? So a system of linear inequalities is two or more linear inequalities that are graphed together. Just like when we did systems of equations and we would graph the two lines on the same coordinate plane. But in this case, both of our inequalities will have shading, and that leads us to the solution. The solution is the overlapping region of points that satisfies both inequalities. So we'll have an area in which the shadings overlap, and any point in the double shading, that means it will work for both inequalities. So let's try a couple and see how we'll do. So let's start here with number one. These are both in slope-intercept form. So they're a nice one to start with. So I'm going to do the top equation first. And that's, we're going to start with our y-intercept of -1. And we have a slope of -1/1. So -1, right 1, -1, right 1. Okay, so here's my slope. And this is a not equal to, because there's no equal to sign underneath. That means we're going to have a dotted line. So I'm just going to turn this into a dotted line. Okay, just like we were doing previously. Now, the y values are greater than the line. So when I go to my y-intercept, greater than y is -1 is above it. So I'm going to shade this whole area. I'm going to do this in pink. All right, so any point in this region will satisfy that line. Okay, now I'm going to do this second line, graph it. It's going to start at -5. Okay, and it has a slope of +1. Okay, and it's also going to be a dotted line, so I'm going to make a dotted line. And this one says the y's are less than, so if I go to its y-intercept, y's are less than -5 down here. So I'm going to follow the whole line here. This whole line. And I'm going to shade this in. Okay, so I have pink solutions only work with this line. Blue solutions work with this line. Purple solutions, where the pink and the blue crossed over with each other, they work with both lines. So this is our solution. So I'm going to put an S on there for solution. All right, let's try this again. Let's look at number 3. Number 3, one of these is in slope-intercept form, but the other one isn't. So let's make it be in slope-intercept form. I'm going to subtract the x from both sides. So I get -4y is less than or equal to -x plus 24. Divide everything by -4. And I get y is going to be greater than, because I divided by a negative sign, so it changes the direction of my inequality. -1 over -4 is a +1/4 x. Positive 24 divided by -4 is -6. So let's graph that one first. 1, 2, 3, 4, 5, 6. There's our -6. This says rise 1, run 4. Okay, and we can go opposite. I need a solid line here. And I want to shade greater than. Where the y is greater than this y-intercept, that would be above it. So this is all my greater than area. We're going to shade this in. Make sure you follow the line. All right. So that's what we used to do. Now we're going to add the second line on. We're just going to use the same graph. We're going to cross at +1. And the slope is +2, which means rise 2, run 1. Rise 2, run 1. I can drop and go left 1 also to continue my pattern. And then this line is also a solid line because it's equal to. So I'm just going to connect all my dots together. Now, I need the y's are going to be less than. So I'm going to go to that line's y-intercept here at 1, where the y is less than this line, and that's below it. So make sure you follow the whole line that we just graphed. So we want all of this. Okay. Now that we've got that, that's going to be our solution area. Okay. We'll keep trying, so you keep getting a little more experience. We'll go ahead and try 4. It kind of mixes a couple of our different line types. We have an x is less than -4. When it's an x and a number, that's going to be a vertical line. This one's where x is -4. But remember, x is -4 at all of these points. All of those. Okay, and it's going to be a not equal to, so I'm going to make this be a dotted line. Now, where is x less than -4? That would be to the left. So I'm going to follow the line that I graphed. I'm going to go ahead and shade all that in. Okay. Then our second equation, we're going to have to transform it into slope-intercept form. So I'm going to subtract the 3x from both sides because I need y by itself. And I get 2y is less than or equal to -3x minus 2. If I divide each of these by 2, I get y is less than or equal to -3 over 2x minus 1. So I'm going to graph my slope-intercept. This says go down 3, right 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And I'm going to go up and left. 1, 2, 3, 1, 2. 2, 3, 1, 2. All right. This is going to be a solid line. So graph a solid line. And my y's are less than. So go to the y-intercept for that line. Less than is going to be below it. So you want to go all the way along the line. So I like to color that portion first when I can. All the way along the line. And then I'll finish out the rest of it. Okay. So you have this tiny pink area. Now anything up here will work for the pink. We just can't see it all. We got this purple area, that's our solution, and then the blue is for just the blue one. All right, let's flip this over. Let's go ahead and try number 9. So neither one of these are in slope-intercept form. That happens sometimes. So we're going to move the 3x over. You always want to move the x term over if you're trying to get into slope-intercept. And I get -y is less than -3x plus 6. I don't want to know about -y. I want to know about positive y. So I'm going to divide each of those by -1. And y is now going to be greater than 3x minus 6. We had to flip our inequality because dividing by a negative number. So let's do our y-intercept first at -6, and our slope is 3, and it's really over 1, so rise 3, run 1. Rise 3, run 1. Okay, we have a dotted line here because it's not equal to. So I draw in my dotted line. Y's are greater than, so go to the y-intercept. Where the y is greater than -6, that would be above it. So I'm going to follow the line, graph it in, and we'll shade all of this. Okay. Now for our second inequality, I'll move the -3x over. And I get -y is greater than -3x minus 2. Divide by -1. And you have y is now less than 3x plus 2. Now these have the same slope. If we were just doing a system of equations, that would tell us these are parallel and there's not going to be any solution. But because they're shading and there's more than one point that can be a solution, we have to check this. So we're going to go to our y-intercept of +2, same slope, rise 3, run 1. And if you want to go the opposite way, down 3, left 1. Okay, this is also a dotted line. See how they're parallel? But let's look at the shading now. It says the y is less than the line. So I'm going to go to the y-intercept for this graph. Less than will be below it. So I'm going to shade below the line. And it's going to get all of this. So we can see this between the two lines is where they both are shaded. So that's our solution area right there. All right, we'll do one last one with the application at the bottom of the page. Sarah's pet store never has more than a combined total of 16 cats and dogs. She also has more than 9 cats. Write a system of inequalities to graph to show the possible number of cats and dogs. So we have cats and dogs. So I'm going to say X is cats. Okay, I tend to go in the same order that they're written. Y is dogs. And I never has more than a combined total of 16 cats and dogs. So cats plus dogs is never more than 16. She also never has more than 9 cats. Okay, so that means we know about the cats are never more than 9. So we're going to just graph both of these. So let's go with the bottom one. It's already in the form that we can use. So where X is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a vertical line, and it's going to be a solid line because it's equal to. Okay. And we say X is less than 9. So I'm going to follow that line. Now this is real world. I want to point that out. In the real world, we can't go out of the first quadrant. So I'm only going to shade what's in this first quadrant here. Okay, because that's where the real world exists. Now let's try our second equation. We're going to have to put it in slope-intercept form. So that one's going to give us y is less than or equal to negative x plus 16. So the y is by itself. We don't need to divide or anything. So let's start where y is 16. There we go. And our slope is negative 1. So that's down 1, right 1. And I like to put the pattern in. It helps me draw the line when I go back to draw the line. I'm going to stop in my real world here. This line is solid because it's equal to. So I'm just going to connect all of my dots. And it says the y's are less than. So I'm going to go to the y-intercept for this graph. And where it is less than is down here under the line. So I'm going to follow the line first to make sure I get the whole area. So all of this, and remember to stay in our first quadrant. So doing this, we would be able to answer questions. Could there be 10 cats? No, because it has to be less than or equal to 9. Anything that's going to work has to come from this purple area. That's the only combination of dogs and cats that we're going to get. So this is your dog counts. This is your cats count. Nope, I did that backwards. That's your dogs. That's your cats, because cats are X. Sorry about that. And so if we have 1 cat, we can have any number of these number of dogs. We have 2 cats, we can have this number of dogs. If we have 3 cats, we can have this number of dogs. So any point in here that if we were to plug it in works for both inequalities. Hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.